Good evening to all. Is the audio and video clear to everyone? Thank you. Sorry for the delay in getting the connection back. So, very good to see you all. So, this session is meant for ordinary differential equations, introduction as well as the fundamental class to start that. So first of all, I request the new users who are attending for the first time, please ask your queries. Later on, I will start my session. Okay, you please proceed. You can ask your doubts. I think you are hearing me, right? Yeah. Marks for ODE, the minimum concentration is 30 marks every year, the minimum. Books, I will give the list of books. Then weightage I have already mentioned, 30 marks minimum for every year. It comes under paper 1. And I will say that it is the easy and scoriest part in paper 1 compared to other topics of paper 1. So the at most classes, if you have the prior knowledge with regard to ODE, at the most 20 hours is enough to cover all. However, if you want a little refresh with regard to Laplace transforms, it takes up to 30 hours. Fine? Okay. Any other queries, please? Yeah, classes will be continuation. So, which topics we can leave are least important to clear this exam mains? Books for reference, right? I will go for that. May I know, you are asking for paper 1 or also as well as paper 2 for leaving topics for overall syllabus, right? So compared to paper 1, so the easy and scoring topics are solid geometry, ODE, vector calculus, and part of linear algebra. If you have good fundamentals with regard to calculus, you can go with calculus 2. Otherwise, you can skip this part, the calculus part. And one more thing is there, that is statics and dynamics, right? Am I correct for that? Yeah. So you have the knowledge and clear understanding over this topic, you can go, otherwise you can skip. I can say compared to previous 3 to 4 years, weightage and priority is given to statics also. So you need to prepare some fundamental concepts with regard to this portion, so that you can say the overall view about paper 1. Okay? Is it that sufficient for you? Fine. Now I go to paper 2 then. Shall I? Okay. So with regard to your perception, may I know your background of academic, either BTech or BSc or MSc? Engineering, which stream? CSE or mechanical, right? Applied sciences mainly, fine. Then Compare it to paper 2. The easy and scoring topics are numerical methods. TDE is mainly known to everyone. Linear programming. Real analysis. However, a little stress is needed for you since nobody has prior knowledge with regard to real analysis earlier. And then mechanics, you can take it as an optional thing. And later, you can go with the part of complex analysis. I can also tick for that. And later on, you have abstract algebra. However, majority of the students has to learn abstract algebra, real analysis, and mechanics, I will say. Am I correct for that? So, in order to get a good score and good weightage, since the remaining topics are known to you, linear programming you have to learn in depth again and PDE in depth again. Among the 3 topics, you need to concentrate at least 2 of them. Of course, up to the fundamental ways or the orientation of the questions asked in UPSC. I will say whatever the unit you consider, if we say that each unit will be bifurcated into 2 parts, A and B. So one question will be posed from part A and other question will be posed from part B. That is mandatory as per the question pattern is concerned. So I will say that for each part, you have to prepare at least half of the thing with regard to weightage of the questions is concerned. And one advantage of these things is, I can't say right now about this mechanics. So for real analysis and abstract algebra, one part is not totally connected with the other part. They are different. The orientation approach is different. That's why you can concentrate for half of the part. So to get a good score, that is the pattern you need to follow. The others are compulsory preparation topics. Right. So apart from this, what are the other questions to you with regard to syllabus concerned? Say. Thank you. So coming to this ODE part, I think majority of you have the strong foundation with regard to ODE earlier. So I can say majority of the students have no idea prior to abstract algebra and also real analysis. So for them, I give the simple suggestion as, if you have the enough time to prepare, so follow us regularly with our class sessions, then you have a good idea with regard to your preparation. And the only thing is, class videos are sufficient for you to get the total content over a particular topic. Later on, you are going to solve the previous year questions. Then it gives a strong foundation with regard to the content what you have prepared. That is enough for everyone, I will say. Right? And how to cover the total syllabus after the prelims within 3 months? If that is our question, may I know how much of the syllabus portion is completed for you? Say. Basics are done. So you are totally distinct with regard to our class sessions, right? You are appearing for the first time, I can say. Yeah. The only thing is, you need to concentrate on the previous year questions first. Let me say one thing. Our thing is not to solve each and every question in the whole question paper given, right? We accept for that. We have to get a good weightage and good score. If that is our concentration, I can say for each student, we can say some merit and demerits are there. In other words, strong points and weak points you can concern. So I can say as for the merit, you take the, I will say the topics which you are good at, and you give the full preparation for them, and for them you cover all the previous year questions. And the contents which are totally different for you, or you are learning for the first time, or you have to pay much concentration over them, you need to prepare them with regard to the previous year questions orientation. Because the syllabus framed is very vast, you cannot cover the whole thing within 1 year. The full preparation, I can say. So the preparation will be done in such a manner for the demerit topics what you have. In this manner, you can cover within 3 months. So for the allocation part, you can take hardly 1 to 1.5 months, and the rest of the time will be dedicated for this thing. Fine. So that it will give you a boost up before the exam, whether you have done it or not. Any other queries, please? Please tell. Yeah. So if you are attempting for 2019, let me say the mains part. So, however, for every student, we suggest that 10 to 12 months is the minimum preparation for everyone. That is mandatory in order to get a first attempt success. And it also depends upon your time allocation too. How much time you are allocating for that. At least 4 hours is required per day, so that you are able to get a good score in the exam. For the whole syllabus is concerned with regard to the math optional. Yeah, we all provide the strategy for every student, and we have a Telegram group also, and we will be regularly in touch with you, and our students and the seniors who have got selected from us will give you a good guidelines to everyone, and we will send the link to everyone too. It is apart from coaching. If you say 1.5 hours is meant for coaching time, remaining 4 hours for practice. And if you are good at understanding this coaching part, you can manage 2 to 4. That is enough. Fine? Right. Sure, let us start our, because many of the students are appearing for the first time. So for that, we have to allocate some time so that they get clarified themselves with regard to doubts. Then we can start. I think we are done with the doubts. So let me give you a rough view. Okay, what is the procedure of the starting procedure? I didn't get you actually. Yeah, syllabus, right. I will give the overall view to everyone. Now, with regard to math optional, I am saying the first one is if you are with us. So I will say that we dedicate 10 to 12 months coaching for total syllabi, so that the whole syllabi will be completed. And simultaneously, in the coverage of syllabi, we will regularly clarify your doubts and help you in solving previous year questions. and also we will give the daily tests for your regular practice. And later on, we conduct the test series comprising around 25 tests on topic wise and also grand tests. On par with UPSC equivalent model. I mean, the level of the questions, so that you have a clear idea about your capability with regard to your performance in the main examinations. So that if you are done with this, then you just have to concentrate on with your GS papers and other things. That is enough for you. There is an overall strategy for every student with regard to our stream is concerned. Okay. And for each topic, how many hours will be allocated, what are the sample videos, and what are the total time taken by us will be posted in the website. You can access that at your free time. Right. Now, if you allow me, I will start our today's session then. Shall I? So for the test answers, you can scan them by CAM scanner and you can upload that. And the other thing is, we will supply the test booklet for you to all students prior to start the test series, and you can write your answers in that. You can send a soft copy, or if you are comfortable, you can send a hard copy too. Okay, to our address. We will assess that and we will give our comments to you. And majority of the students are done with soft copy. They can have our comments on them. Thank you. And for test series, the students are requested to enroll their names prior to start the test series, so that we can know how many test booklets we have to supply to each and every one. That's it. And you can see the respective links on our website. Okay. Let me start our today's session on ODE first. So I will read the syllabi. So please take a note of that. Formulation of differential equations of first order, first degree, integrating factor, orthogonal trajectories, first order but not first degree, Clairaut's equation, second and higher order differential equations, Cauchy-Euler equation, variation of parameters, and then Laplace transforms. In a brief model, we can say the total syllabi is given like that. Okay? Please take a note of that. Then I will give a overview on what topics we need to concentrate with regard to UPSC model. Single solution come under the parts of Clairaut's equation and later on. I will subdivide each and every topic, right? So that you have a clear idea. After noting this syllabi, please inform. I will go further. Shall I continue? Fine. As I have mentioned earlier, the whole syllabi will take to cover 20 to 30 hours. Depends upon your approach to learn. That is one thing. And coming to previous year question papers, with a rough analysis, we can say that main concentration will be given to the problems on second and higher order equations, Cauchy-Euler equation, and variation of parameters. As I have mentioned, each unit will be subdivided into two parts, part A and part B. So in part A, we need to concentrate on these things. So whenever a question is posed on them, the weightage will be 15 marks or at least 10 marks. So majority of the questions are posed from these areas. And obviously, one question in general will be dedicated on Laplace transforms, usually to solve the differential equations using Laplace transforms when the initial condition is given. Sometimes some other questions will be asked, finding the inverse Laplace transform, etc. The usual question we can expect is solving an ODE by means of Laplace transforms. However, whenever the compulsory part section is there, the section A part, so we can expect a 10 marks question typically on orthogonal trajectories or integrating factor or first order but not first degree. However, in the equations of first order, first degree, we have one small topic is there, which is nothing but linear differential equations. And we can say that formulation of DE, generally no question will be framed if we consider the weightage of the previous years. So this is the overview to concentrate on what topics we need to focus with regard to our preparation. And as per the class orientation is concerned, since majority of the students have prior knowledge with regard to these topics, as we have studied earlier, I can say this will be a refreshing thing for you for the basic topics. I will start and I will give what is the solution approach for a particular problem, and randomly I will take one or two problems on each subtopic. Okay. I am saying that formulation of differential equation is nothing but whenever a general equation is given, by differentiating that we are going to get the corresponding differential equation, right, by eliminating the arbitrary constants given in that equation. So generally questions are less asked on this concept. Fine. In general, while doing the problems on orthogonal trajectory, we have to formulate the differential equation for the given equation. So this part will come automatically here, so that it will be neglected. Okay? Right. And coming to textbooks which you need to study, I will say, since majority of the students come across with BS Graval or any other engineering textbook of volume 1 which we have studied, that is sufficient. Later, ordinary and partial differential equations by S. Chand Publications, written by M.D. Rai Singhania. Then you can take differential equations part covered by S. Chand Publications or other, and exclusively S. Chand Publications book is available for Laplace transforms. You can follow that exclusively for Laplace transforms. So you can please understand one thing, that whatever the book you follow, it basically gives the information and problem solving approach with regard to concerned topic. It is just for your understanding, to have the basic content and basic idea to solve the problems. That's it. And don't expect that questions are directly given from the textbooks itself. You should not say always. Fine. But we prefer textbooks which cover a lot of examples and give a good idea in solving the problems. That is my intention on the whole. Accepted? So, however, to solve the questions, we have previous year questions are there already. While solving them, we can have a good ideology on the level of questions asked. Okay, you can follow Krishna series 2 with regard to differential equations. So BS Graval textbook is there for engineering mathematics, in which differential equations is a part of it, isn't it? That's why I said you can follow any engineering textbook volume 1 which gives the knowledge with regard to differential equations. Because in first year, first semester, usually differential equations will be given there. Accepted? Right. Okay, right. So let us start the session first. I think everyone has the idea of what is a differential equation, what is order and degree. Is it required for you to start right from that part? Right. Usually coaching will be given for the whole syllabi. For selected topics we are not allowing. However, you can attend the classes for selected topics for joining the whole course, because the motto will be changed if you choose selective topics. That is the thing. However, you can have the sample videos available in the website, and you can have the free classes whenever a new topic is going to start. On attending them, you can have a rough idea whether it is good for you to prepare or not, so that you can decide yourself whether to join with us or not. Thank you very much. So, in today's session, first of all, I want to give the approach with regard to the problems based on exact differential equations followed by integrating factors. Later on, I will go with problem solving approach with regard to linear differential equation, and also nothing but the Bernoulli differential equation. So this session I want to dedicate over these topics. However you have come across with them, I will start again once with these things. Okay? Shall I start then? Thank you. So these topics come under first order, first degree differential equations. Now, as we know, what is meant by an exact differential equation? Whenever we consider a differential equation of the form some value into dx, some value into dy equal to 0. Usually for the coefficients, we use the symbols that mdx plus ndy equal to 0. We call it as an exact differential equation if it satisfies the condition that if you consider the partial derivatives dou m by dou y and dou n by dou x, these two must be equal. However, if we look at the definition, a differential equation is called exact if there is a function f of xy such that if you differentiate the function partially with respect to x and y, the coefficients will come. That is the actual meaning with regard to exact differential equations. However, this condition is used to test whether the given differential equation is exact or not. So, as far as problem orientation is concerned, whenever a differential equation of this form is given, we straight away calculate these two values. If they are equal, we say that it is an exact differential equation. And what is the approach to solve that? First one, you have to integrate m with respect to x partially. So, if any y term is there, it will be treated as a constant in m. Secondly, this value, let me say this is y or v, let me say this is v. Then you differentiate that value with respect to y partially and subtract it from n and integrate this value with respect to y. And by adding these two, by taking the integration constant c, which gives the general solution. So this is the approach in solving the exact differential equation. However, apart from calculating this, some others use the technique that we integrate n such that we take the terms of n which do not contain x, and we integrate this value with respect to y. Yes, whenever you do this thing, it contains only y terms and you are going to integrate with respect to y only. So we can call it as a partial integration too. Okay, right. So in doing the regular problems, we use these two steps to determine the general solution. So what is the first thing? The given equation will be verified by checking this condition. Later, we integrate m with respect to x partially. Then we choose the terms of n which do not contain x. In other words, we take the terms of n which contains y variable only and integrate with respect to y. That's it. And these two values will be joined together to give the integration constant c. This is the solution approach. Clear? Any queries? Say. Right? I will take the example. If the approach is clear to everyone, I will go with the example. Shall I? Thank you. So by taking the problem, you have the clear idea. Let me take it first. Just hold on a second. I will pick up a problem for you to get an idea. Please note down that problem. After that, please inform. Yeah. Is it over? So if you compare the given equation with m dx plus n dy equal to 0, so y into sine 2x dx is m and this value is n. So to check the exactness, let us calculate dou m by dou y, differentiating m with respect to y partially. So sine 2x will be taken as a constant. So differentiation of y is 1. It is sine 2x. Coming to differentiation of n with respect to x partially, it is nothing but dou by dou x of minus y square minus cos square x. Since you are doing differentiation with respect to x partially, it is treated as a constant, so its differentiation is 0. And for this, the differentiation is minus of 2 into cos x into cos x differentiation is minus sin x. As we apply the formula d by dx of x square. So this is nothing but the value sin 2x. Accepted? So the two values are equal, hence the given equation is an exact differential equation. Okay? Is it clear or not? Please tell. Then let us go for the integration part. So we have to integrate m with respect to x, nothing but treating the y term as constant. So this is equal to integral y sine 2x dx. So y is nothing but a constant. So integration of sine 2x is minus cos 2x by 2. So this is minus cos 2x by 2. Clear? Say. Right. Now we have to integrate n minus so if you say that this is equal to v. So can you differentiate this thing partially? Yes or no? Right? And can you integrate that part also? Are you getting the idea here? What I am writing? Right. So this value and the value obtained here will be written together. And apart from calculating this part, you can use the other technique as terms not containing x. So this is nothing but minus y square dy. This is equal to minus y cube by 3. So the main solution is given by minus y into cos 2x by 2 minus y cube by 3 equal to integration constant c. So apart from doing like this, you can follow this technique also for the second one. Okay? This part or this one? This part? This thing, right? Okay. Here, apart from doing this entire procedure, I am integrating the terms of n and I am choosing the terms which do not contain x. In other words, I will pick up the terms having y individually. So this is cos square x. I don't consider this. This is exclusively y square. X is not presented here. I consider only this term and I will integrate with respect to y. So it is minus y square dy, nothing but minus y cube by 3. Okay? So that this solution and this solution will be joined to get the general solution. That is the procedure. Okay? Are you getting the idea? Yes, the problem is completed. So what is the first thing we are doing? We check for dou m by dou y is equal to dou n by dou x. Yeah, I will compute that using first method too. Then we have to integrate m with respect to x partially, treating that y is a constant. Then we choose the terms of n which contain y only. We integrate them. This solution and this solution are joined together, which is nothing but the general solution of the problem. Okay, and here coming to this part, here I have written n minus dou v by dou y. So I have to differentiate this thing partially. So what is the value here? It is nothing but then we have to integrate the remaining thing. Am I correct? Say, are you getting it or not? Yeah, just hold on a second. I will make space here. And how can we write this value? Minus cos square x. We can write it as on simplifying. I am writing the answer. You please check on that. It is 1 by 2 cos 2x, let me say, cos 2x. If we calculate LCM, what will be the value there? Cos 2x gets cancelled, isn't it? So 1 will be there. Since minus is presented, you have to take the respective value. So integrating, the value is minus 1 by 2. Exactly. Exactly. Answer is not same as earlier. I have especially chosen this problem to give you the difference between the previous method and this method. Please understand, in 99% of the problems, the solution given by the first method is always correct, what we have done earlier. So there are some typical problems in which the answer varies actually. So the actual procedure is defined in this way. So for the second part, while doing the integration of n terms, we have to do like this only. But in general convenience, while doing the problems also, we go with the previous procedure. So always it gives a correct solution. So in general, we stick on to the previous method, but there are some typical cases in which the answer varies. That's why I have chosen this example for you. Okay. Are you getting the idea? Yes or no? Let me take one more problem which give you a good idea in solving this. In majority of the cases, we use the first method. We give less priority to this. The first method holds good always for every problem. For some typical problems only it varies. Okay. Let me take one more problem which gives you very good idea. Fine. Let us take one small example for you. Please note down this problem. Let us have a random discussion. Since the terms are very simple, yeah, I will explain one more time, right? So verify yourself, is it exact or not? Please tell. So all of you agree? Thank you. Now, let us do the integration. Integration of m with respect to x partially. So if you do the integration, it will be 2x square plus 3xy plus x. Accepted? All of you? The integration value. I am waiting for your reply. Right. Now here, terms not containing x. So, in the entire part of n, you choose the terms which do not contain x. So, I have to take these two only. So, the answer is y square plus y. Accepted? Now, these two solutions put together to give the general solution. So, nothing but 2x square plus 3xy plus x plus y square plus y equal to c is the general solution. So, at this part, you can perform the other way round as so n is nothing but 3x plus 2y plus 1 minus of, you have to differentiate this term partially with respect to y and you have to subtract that. So the answer is 3x. So it is nothing but integral 2y plus 1 dy. Accepted? So the same answer will come again. Please check. Are you getting the idea? All of you? So in the previous problem also, I have done the same thing. So here in this problem, these two things are coincided. Accepted? There is no difference. So apart from doing partial differentiation and subtraction, in general, whatever the x terms are there in n, they will come. The x term may be individually presented there or x will be multiplied with y, whatever it may be, it will come here. So while doing subtraction, these things gets eliminated and you have y terms and constant will be there exclusively always. So to avoid this tedious procedure here, always we stick on to the first method, choosing terms of n not containing x. So while doing problems, we always stick on to this method only, which is convenient. However, if you have any doubt with regard to this solution, yes, this is first method, doing m and doing n like this. So we always go on for the first method and write the general solution. Whenever you have a doubt, then only we stick on to this method. Fine. So in doing problems also, we stick on to this procedure only, not this thing. Accepted. You can check with other exact differential equations also. So any queries for anybody with regard to exact differential equation? Yes. In rare cases only we use second. That's why I have used that 99%. We always have the first method convenient. The second method is this. We calculate m in the usual manner. In n, what are the terms we are selecting? We are leaving the terms which contain x and we are taking the terms which contain y and constant only individually in n here. But the actual formula is defined as, you write the values of n here and you subtract the terms by differentiating this solution partially with respect to y. That is nothing but dou v by dou y. That net result will be integrated with respect to y because it gives only x terms. So x terms gets cancelled here. This is the second method for selecting the terms in n. Okay? You got the idea now? Fine. Shall I continue then? This is the tough question you are feeling. The toughest part you are asking, right? In these exact differential equations. Okay. I cannot say the toughest one. The whole thing with regard to differential equations is simply based on your integration techniques and partial differentiation techniques. I am saying the simple thing that whatever the question is there, always we stick on to the first method. Second method we will never use in the examination point of view. Whenever a typical question is there, where you are not getting the answer, in such cases only we use the second method. So forget about second method, stick on to first method always. Please understand that. I am giving that textbook ideology. Some others have defined like this, some others have defined like this, and this is the convenient way in solving the questions. So that without any confusion, you are going to solve the problem straight away. Accepted. And ODE is the easiest one. So however, one person has asked that, let me take a simple problem. It is simply based on your differentiation and integration techniques. How good you are and how knowledgeable you are with regard to the formulas. So please take a note of this one. One plus e power x by y dx plus 1 minus x by y into e power x by y dy equals to 0. Clear? After noting, please inform. So this is nothing but m. This whole part is nothing but n. So are you able to differentiate partially with respect to x and y? All of you? Any doubts? Or you want me to do the differentiation here? Okay, right? So if you consider dou m by dou y, so one is a constant, its differentiation is 0 for e power x by y. So you just feel it as it is of the form e power ax. So how do we differentiate? A into e power ax, right? The differentiation part. So here it is e power x by y into x. Why? Because here x is treated as constant because you are doing with respect to y the differentiation. And the differentiation of x by y here, if you consider minus 1 by y square. Okay. So this is nothing but minus x by y square into e power x by y, the partial differentiation part. Accepted all? Right. Then coming to n, so for n with respect to x, one differentiation is 0. Here you have x by y into e power x by y is there. Since you are doing with respect to x partially, here it contains two terms. Apply the product rule differentiation here. So x by y into e power x by y differentiation e power x by y into 1 by y, because here you are doing with respect to x, plus e power x by y into x by y differentiation 1 by y. Accepted? And can you simplify that? And tell me whether it is exact or not. Okay. So in this manner, we are going to check the exactness of the differential equation. Clear? So any other queries, please? So if you are clear with solving how to solve the exact differential equations, then I will go with the integrating factors. Shall I? Okay. Yeah. So did I do the differentiation correctly? Yes. So it is right? Now, since the time is running out, I want to give the idea of integrating factors and the approach in solving the problems, so that in the next session, I am going to take the list of problems and solve them one after the other, which gives you a good idea over integrating factors. Integrating factor is a function sometimes a constant which is useful in making the given differential equation as exact. So, in a simple manner, let us consider the differential equation mdx plus ndy equal to 0, and it is not exact. Now what happens? I want to make this equation as exact, so I will multiply this equation with a suitable function or sometimes a number, so that the given equation will become exact. And for a given equation, integrating factor is not unique. You will have so many integrating factors. Depending upon the merit of the function, the differential equation you have considered, we will pick one formula which is useful to determine the integrating factor. So in general, I will say we have 5 formulae, nothing but integrating factor formulae are there to determine the integrating factor of given differential equation. Okay? Are you getting the idea? What is meant by an integrating factor? Fine. I will list out the formulae one after the other. First one is one by mx plus ny. Second one by mx minus ny. Third one, fourth one, and fifth one. So usually these are the 5 standard formulas which we use to determine the integrating factor. Now, I think all of you know what is meant by homogeneous function or homogeneous differential equation, right? Yes or no? Is it known to you or not? Please respond. Okay, let me give the simple idea. Please take that. This is the differential equation. What is the power here? 2. Here the power is 3. Here the power is 3. If the whole equation, each term has equal power, it is called homogeneous differential equation. So if it is x cube here, each term possesses the equal power, so it is a homogeneous differential equation. Accepted? Now, whenever the given differential equation is homogeneous and not exact, so 1 by mx plus ny is the integrating factor, provided this value is not equal to 0. So we use the formula 1 by mx plus ny if the given differential equation is not exact and each term has equal power in it. Clear to everyone? Say. So after finding 1 by mx plus ny, we multiply the given equation with that. It becomes exact. Right away, we apply the previous procedure. Hence, we can solve it. Clear to all? Yes or no? Right. Second one is 1 by mx minus ny. So, when the given equation is not homogeneous, so if you take the previous case like this, right away on observation we can say that it is not homogeneous. In that particular case, we are going to check with this. How to check? So, if you are able to write the given equation as so y into some value dx plus x into some value dy equal to 0. In other words, in m you are able to common y, in n you are able to common x. So after doing this, we calculate this value mx minus ny. If it is not equal to 0, then 1 by mx minus ny is the integrating factor. So by multiplying with that value, the given equation becomes exact, hence we can solve this. So whenever these two cases gets failed, then we come up with the remaining 2 or 3 formulae. I will go with the examples too. So first of all, note down the key points and the procedure. So once you know where to use them, you are able to solve any kind of problem. Fine. I think all of you have done integrating factors earlier at BTech or BSc level. Am I correct? So it will be just a refreshing one for you. Which formula is applicable and where? That is why I am giving the summary of that. Okay. So coming to third one, if the first two gets failed, in this or this 1 by n into something or 1 by m into something, you can pick up any one formula. You can start with any one, either this or this. If you have calculated this value, it must be a function of x or constant. That means after calculating this value, you should get just like x, x square, e power x, like that. A function of x only should come, or a number should come, like 1, 2, 3, etc. Then e power integral f of x dx is the integrating factor. So if you evaluate 1 by n into something, the result should be a function of x only. It should come like x, x square, x cube, like that. Then e power that value, e power integral x, e power integral x square will be the integrating factor. Okay. The same thing is applicable for 1 by m too. If you simplify this, it must be a function of y only. So we will discuss this case separately at the end. So please note down these 4 formulae first. Then I will take the problem solving session on them one after the other. Okay? Yeah. So let us stop this part here. X power h into y power k, just like x square y cube by x, like that. That is the last formula.